Want the ultimate AI secrets? Discover expert techniques that bypass standard limits and unlock advanced reasoning. These hidden strategies will transform how you prompt. Hit subscribe before we dive into the code. First, step-around prompting. Strategically reframe requests. Test AI safety guardrails and expose hidden biases. Next is react. Combine reasoning with actions to let AI dynamically gather data from external environments. Then, tree of thoughts. Force deliberate problem-solving by exploring multiple reasoning paths and looking ahead. For massive tasks, use least to most. Break complex problems into simpler, sequential subproblems for easy solving. Finally, constitutional AI. The AI automatically critiques and revises its own responses, using core principles.
Welcome to today's explainer. Step right into our futuristic AI laboratory. Today, we're moving way beyond basic text inputs. You know, those straightforward queries we all use every day? Yeah, we're leaving those behind. We are entering the realm of advanced prompt engineering, where we're essentially programming the neural boundaries of these language models. If you've ever felt like your AI assistant just totally hits a brick wall on complex problems, you are definitely in the right place. So get ready, because we are about to explore how to completely override default system behaviors. Okay, let's dive into this. We all know standard language models are absolutely incredible at pattern matching, right? But what happens when they face highly complex, multi-step problems, or maybe ethically gray tasks? Even standard chain of thought prompting, where you just ask a model to think step by step. Well, that has its limits. When the baseline just isn't cutting it, we have to leverage some highly specialized architectures to literally force the model into deeper cognitive processing. So here is our holographic diagnostic menu for today's explainer. We've got 5 specialized power-ups to master. 1, mastering complex reasoning. 2, combining reasoning and acting. 3, testing the AI boundaries. 4, aligning with constitutional AI. And finally 5, the future of prompting. Let's get right into it.
Section 1, mastering complex reasoning, pushing the cognitive limits. To really push the cognitive limits of what a model can figure out, we first need to set our baseline. Take a look here. Standard zero-shot prompting is where the AI basically just guesses the final answer directly from your input. Then, we have chain of thought. This is where the AI actually outputs a coherent series of intermediate natural language reasoning steps right before giving the final answer. It's kind of like making a student show their work in math class. But as we're going to see, even this baseline completely fails when we ask the AI to generalize from easy examples to much harder problems. So, enter our very first cognitive upgrade, least to most prompting. This is honestly a brilliant 2-stage remedy that's actually borrowed directly from educational psychology. When you teach a human student a really complex skill, you use a progressive sequence of prompts, right? Well, for AI, it means forcing the model to first break a complex problem down into a list of much easier subproblems, and then solving those subproblems sequentially. It's a highly structured way to help models tackle problems that are way harder than anything they ever saw in their training data.
Now, what's really interesting about this slide is how this system feeds its own outputs right back into itself. In stage 1, it just decomposes the question. Simple enough. Then in stage 2, it actually begins solving. But here is the real magic trick. To solve the next sub-question, the model appends its previous answers into the prompt in a continuous loop. So, solving a given subproblem is heavily facilitated by the context of the previously solved subproblems. It's building its own ladder.
And the results of this continuous loop? Absolutely mind-blowing. When researchers applied least to most prompting to the Code DaVinci 002 model on the SCAN compositional generalization benchmark, they saw a massive data-driven wow moment. Standard chain of thought sat at a really meager 16% accuracy. But by breaking the problem down, the model jumped all the way up to 99% accuracy. And get this, it achieved this near-perfect score using just 14 exemplars in the prompt. That actually outperformed specialized neural symbolic models that were trained on over 15,000 examples. Crazy, right? But think about it. What if a problem doesn't just need breaking down? What if it requires actual strategic planning? Well, for that, we bring in the tree of thoughts, or TOTI. This is our next major cognitive upgrade. It shifts the model from simple token-level left-to-right guessing into deliberate problem-solving. It literally allows the AI to explore coherent units of text, which we call thoughts, evaluating different paths before committing to any single action. Let's compare them directly to see why this matters. Chain of thought is strictly linear. It's rigid, left to right. If the model makes a single mistake on step 2, well, the whole final answer is pretty much doomed. Tree of thoughts, on the other hand, is a dynamic branching structure. It actually allows the AI to self-evaluate its choices, look ahead to potential consequences, and crucially, backtrack and retreat to try an entirely new path if it realizes it's stuck. It's basically the difference between walking a tightrope and intelligently navigating a maze. If you want proof of how powerful this cognitive tree orchestration really is, just look at the game of 24 task. It's a math puzzle that requires serious strategic look ahead. With standard chain of thought, it only managed to solve 4% of the tasks. It just couldn't plan ahead. But when they flipped the switch to tree of thoughts, that success rate skyrocketed to a staggering 74%. Just by allowing the AI to branch out and self-evaluate, its strategic planning capabilities were drastically transformed.
Section 2, combining reasoning and acting, the REACT paradigm.
So here's the catch. Even the absolute smartest, most elaborate reasoning trees will ultimately fail if the AI is just trapped in a box, unable to interact with external data. And that brings us to REACT. REACT is a paradigm that synergizes reasoning traces with task-specific actions in a strictly interleaved manner. It's basically our method for creating dynamic plans where the AI acts to reason and reasons to act. It doesn't just sit there and think, it thinks, does something in the real world, observes the result of that action, and then thinks again.
The superpowers that REACT unlocks are just highly practical. By prompting the agent to actually gather external knowledge, like, say, interfacing directly with a Wikipedia API, REACT drastically reduces those annoying hallucinations you see in standalone chain of thought. If it doesn't know a fact, it goes and searches for it, rather than just making something up. It completely overcomes error propagation and creates really interpretable reasoning trajectories. In fact, on interactive decision-making benchmarks like AlphaWorld and WebShop, REACT easily outperforms imitation learning methods trained on tens of thousands of instances. And the best part? It allows humans to jump right in and edit the AI's thoughts on the fly to correct its path.
Section 3, testing the AI boundaries, Steparound prompting. All right, I'm going to guide you into the cybersecurity wing of our holographic lab right now. We're keeping things very neutral and scientific here because we are exploring how to rigorously test the ethical guardrails of AI. The technique we're focusing on is called step-around prompting. This is a highly specific adversarial boundary testing subtype of prompt engineering. The user basically deliberately reframes, sequences, or contextualizes their requests to probe or expose the limits of the AI's safety filters. Now, it's super important to understand this isn't some malicious hack. In the realm of academic ethics, this is actually a structured diagnostic mechanism. We use it to reveal hidden biases and safeguard instability. So, the crucial point is right here in this quote from the research. Step-around prompting indirectly recontextualizes a request. It literally alters the model's interpretation of risk. By just shifting the framing, the tone, or the authority cues, like, for example, telling the AI it's acting in an academic audit rather than just a casual chat, the model suddenly treats a restricted request as entirely permissible. It really exposes that fascinating tension between the model's safety alignment and its built-in desire to comply with human intent. Because of its obvious dual-use potential, researchers have proposed a very strict operational framework for using step-around prompting, specifically in higher education. Look at the two main pillars supporting this audit process. On the left, we have technical safeguards that ensures robust data curation and adversarial training. And on the right, ethical governance, ensuring harm minimization and crystal clear oversight. It basically takes what could be considered a threat and turns it into a highly regulated, structured method of academic accountability. Section 4, aligning with constitutional AI, rules without labels. Moving to our final protocol, if we can easily step around a model's guardrails, how do we actually teach these incredibly powerful, boundary-tested models to behave safely? And more importantly, how do we do it without relying on an endless, exhausting stream of human feedback? Well, Anthropic developed a method called constitutional AI to solve exactly this. It's a self-improvement loop. Instead of having humans sit there labeling tens of thousands of toxic versus safe outputs, the AI is given a human-written constitution, just a short list of governing principles. In step 1, the AI critiques its own initial response against these principles. In step 2, it revises its own content to remove any harmful elements. And finally, in step 3, a preference model is trained on these AI-generated revisions using reinforcement learning from AI feedback, or RLAIF. The AI is essentially supervising itself. And this brilliantly illustrates the success of that exact approach. Looking at these two charts, as the model's parameters scale up, we see the constitutional AI models. Those are the ones marked with the gray and black lines, achieving incredibly high helpfulness on the left while simultaneously dominating the harmlessness metric on the right. They are achieving this non-evasive harmlessness entirely without human toxicity labels. They're actually outperforming older models that relied heavily on traditional human feedback. Furthermore, as the reinforcement learning from AI feedback sequences progress, you can clearly see the absolute harmfulness score taking a steep, definitive drop. The model is literally learning how to engage with difficult queries by politely explaining its objections based on its constitution, rather than just evading the question completely or, worse, outputting toxic material. The absolute primary takeaway you should have regarding constitutional AI is its staggering efficiency. We can control AI behavior precisely, and with far fewer human labels, simply by defining the right set of explicit governing principles. The supervision is entirely in the rules, not in an army of human labelers trying to manually red team the system all day long.
Section 5. The future of prompting. Orchestrating the lab. Wow, we have come a remarkably long way in this explainer, traversing all the way from basic zero-shot text inputs to orchestrating complex, self-revising, web searching, cognitive branching neural networks. We are no longer just prompting, we are engineering cognitive architectures. From least to most decomposition and the dynamic branching logic of tree of thoughts, to the environmental interactions of React and the ethical boundary testing of constitutional AI, these incredible tools are now right in your hands. So I'll leave you with this challenge. Which of these advanced system overrides will you deploy in your very next AI interaction? It's time to stop just talking to your AI and start programming its thinking.
Which method will you try? Comment below to win a free Claude AI premium subscription. Like, comment, and subscribe to enter. Check the description notes for secret prompt templates. See you!